Hello, in this podcast I'm going to demonstrate some example solutions to equations that are perhaps typical of the kind that come up in the course of one's algebra career. And this first one here we see is 3 parentheses 4 plus x, close parentheses, minus 5 equals 20. And of course the goal anytime we're solving an equation for an unknown variable, in this case x, is to get the x all by itself on one side and then whatever numbers are on the other side. And by numbers, I mean it could be a decimal, a fraction, a mixed number, or just simply an integer. That will be the solution to the equation. And this first one involves the use of the distributive property, which is very handy in solving some kinds of equations. First of all, you have to recognize that I can't really do anything with this x here because it's inside parentheses and linked to this 4 by addition. Okay, so couple of things that we could do. Now the first thing, I'd like to move the 5 here to the other side by adding 5 to both sides. So I have 3 times 4 plus x minus 5 plus 5 equals 20 plus 5. So this becomes 3 times 4 plus x equals 25. Now, two things could happen now. One, I could divide both sides by 3. That would be fine. But just to demonstrate the distributive property, I'm going to actually apply the distributive property. So 3 times 4 is 12. 3 times x is 3 times x, and this equals 25. Now I'm going to subtract 12 from both sides. And 25 minus 12 is the same thing as 25 minus 10 minus 2. 25 minus 10 is 15. Subtract another 2 from that is 13. And to finally solve the equation, I apply the division property of, the division law of equality. And we have x equals 13 over 3. Oops, excuse me. Not 13 over 13, but 13 over 3. 13 over 3. Okay? Now, another type of problem that we can come across is where we're going to have to combine like terms. So, like terms are ones similar to these x's here. I've got 3x's there, I've got a minus 2x there, I've got a plus 5x there, and a plus 3x there. Also, all the constants are like terms as well. Okay? So, on this left side, I can combine everything that has an x to it. And so, if I have 3 x's here, and I subtract 2 x's from that, how many x's are left? Well, just 1 x. I've still got the plus 7. Over here I've got 5x plus 3x, and 5 x's, I take 3 more x's and I add it to it. That becomes 8x, and I have 14 plus 8x. Now I'm going to try to get the x's all on one side by themselves. I could either choose to work with the x's, the variables right now, or the constants. It doesn't matter which way we go. I can see, however, that if I subtract 8x from this side, then there'll be no more x's on this side over here, and there'll be some x's left over here. So I'm going to go ahead and subtract 8x from both sides. And when I subtract 8x from 8x, there's going to be no more x's left over here on the right. The only thing that would be left will be the 14. And I take 1x and I subtract 8x from that. I end up with a negative 7x plus 7. I could just have easily subtracted 1x from both sides. Now I'm going to subtract 7 from both sides. This gives me negative 7x is equal to 7, because 7 minus 7 is 0. 14 minus 7 is 7. Now, what is the final solution here? Well, I'm going to divide both sides by negative 7. Negative 7 over negative 7 is 1. X is equal to negative 1. So to get some progress going on this one, I had just combined all the constants together that I could on one side and all the variables together on one side. Another type of problem that we might run across is we have a fraction in a numerator or denominator on one or both sides. Here I can see that I've got a 2 plus x over here. Now, the most convenient way to solve a problem like this is to multiply both sides by this entire denominator. And so that would look something like this. 2 2 plus x minus 3 over 2 plus x is equal to 9 times 2 plus x. So I have multiplied both sides by 2 plus x. And it doesn't matter what the x is. If I have a 2 plus x and I divide it by 2 plus x, these cancel out and I end up with 3 is equal to 9 times 2 plus x. Now in the previous example of solving an equation using the distributive property, I went ahead and applied the distributive property, which would be 9 times 2 plus 9 times x. That works perfectly well. There's always more than one way to go about solving an equation, and as long as you do it right, the answer is the same every time. In this particular example, I'm going to not do that and show the alternative method, which is to divide both sides by 9 at this time. So this becomes 1/3 is equal to 2 plus x. And I finish it off by subtracting 2 from both sides. Is equal to x. And 1/3 minus 1 is negative 2/3. And so I subtract another 1 from negative 2/3. That's negative 1 and 2/3 equal to x. Okay. One final example here of a type of problem which is not too uncommon. 3 consecutive integers, make that integers, have a sum of 20. What are they? In other words, this problem is asking you to find 3 consecutive integers that have a sum of 20. And I just made this problem up, so hopefully it can be done, and we will find out. But here is the way you do it. One, I decide, well, my first integer, I'm just going to give it a variable name and call it x. Okay? And there it is, x. Now, x plus some other integer right after it, which would be x plus 1. Consecutive means 3 right in a row. So there's 1. Obviously, I add 1 to that integer. That's the next one in a row. And you can probably guess what I'm going to put here, which is what? Well, 2. So there's the first integer, there's the next one, and there's the next one. Now, since I have nothing but plus signs in front of the parentheses here, I can take the parentheses away, and that means the left side remains unchanged. If the left side had some minus signs in front of the parentheses, I would have to change the signs of everything inside the parentheses in order to remove the parentheses. Just a quick example on that. Let's say I had, x plus 3 minus 2 plus 7 minus 4 equals 10. To remove these parentheses, since there's a minus sign in front of it, I would have to go x plus 3 minus 2 minus 7 plus 4 equals 10. Okay? We don't have to do that here because there's plus signs in front of the parentheses. So I can remove the parentheses without penalty, and everything is hunky-dory. So I have x plus 1 plus x plus 2 equals 2. Now I'm going to combine like terms. X plus x is 3x. 1 plus 2 is 3. And this is 20 over here. Okay? So I have 3x plus 3 is 20. Now, I'm going to subtract 3 from both sides. And darn, I can see this isn't going to work. Apparently there aren't 3 consecutive integers whose sum is 20, because 3x is equal to 17, and 17 is a prime number. It's not divisible by 3, so x is equal to 17/3. So this particular problem has no solution because I cannot find 3 consecutive integers whose sum is 20. So if you're confronted with a problem that asks 3 consecutive integers have a sum of some unknown number, you just set the first one equal to x, then the next one is x plus 1, the next one is x plus 2, then we add them, combine like terms, find out what x is, and then let's say if x was 4, that means the 3 consecutive integers would be 4, 5, and 6. Okay? Let me go ahead and try another one right here. Let me find one that I know works. Let's just do that. 4, 5, and 6. Okay? Make one up. I want to make sure I have something that works. 4, 5, and 6, that sum is what? 4 plus 5 plus 6 is equal to 15. So I got 4 consecutive integers whose sum is 15. Let's see if it works. Okay? First one is x plus 1 plus x plus 2 is equal to 15. I can remove the parentheses. Combine like terms. Subtract 3 from both sides. Divide both sides by 3. And this shows that x is equal to 4, because 12 divided by 3 is 4. This means the consecutive integers are 4, 5, and 6. And that, ladies and gentlemen, is how it's done.